88 workers, 2 catastrophic collapses, the same bridge, 9 years apart, and 1 engineer who never visited the construction site. The Quebec Bridge was supposed to be a triumph, the longest cantilever bridge in the world, a symbol of Canadian progress and engineering genius. Instead, it became the deadliest bridge construction disaster in history. On August 29, 1907, after 4 years of construction, the massive south arm of the bridge collapsed in just 15 seconds. 75 workers plunged into the icy St. Lawrence River. Most died on impact. 11 survived with devastating injuries. And 33 of the dead were Mohawk steelworkers from the Cononowak Reserve, buried under crosses made from the twisted steel that killed them. But here's what makes this story even more horrifying. They rebuilt the bridge. And on September 11, 1916, as thousands of spectators watched from shore, the 5,000-ton center span was being lifted into place. At 10:50 in the morning, a sharp crack echoed across the river. The entire span slid off its supports and plunged back into the St. Lawrence. 13 more workers died. The chief engineer behind the first collapse, Theodore Cooper, never set foot on the Quebec construction site, not once during 4 years of building. He made all his decisions from New York City, over 500 miles away. And when on-site inspectors telegraphed him warnings about bending steel and structural problems, he dismissed them. He was wrong. 75 men died because of it. And after the Royal Commission blamed him for grave errors in design and judgment, Cooper faced no criminal charges. He simply retired. This is the story of the Quebec Bridge, a monument to ambition, arrogance, and the brutal cost of engineering mistakes. The idea of bridging the St. Lawrence River near Quebec City had been discussed for decades. By the late 1880s, the need was undeniable. The growing railroad network required a permanent crossing. Ferries were slow, unreliable, and dangerous in winter when the river froze. A bridge was the answer. In 1887, the Quebec Bridge Company was formed to make it happen. But building a bridge across the St. Lawrence was no simple task. The river at Quebec is nearly half a mile wide. The water is deep, fast-moving, and choked with ice flows in winter. Conventional bridge designs wouldn't work. Engineers proposed a cantilever bridge. This design uses massive arms that extend out from supporting piers, with a center span connecting them. Cantilever bridges were relatively new technology, but they had been successfully built in Scotland and India. The most famous example was the Forth Bridge in Scotland, completed in 1890. It had a main span of 1,700 feet. The Quebec Bridge would need to be even longer. In 1900, the Quebec Bridge Company finally secured funding and began construction. The chief engineer for the bridge company was Edward Hoare. Hoare was competent but inexperienced with long cantilever spans.
He had never worked on a cantilever bridge longer than 300 feet. The Quebec Bridge would be 1,800 feet. This was a problem. But the company also hired Theodore Cooper as consulting engineer. Cooper was a legend. He had worked on the design of the original Eads Bridge in St. Louis and advised on numerous other projects. His reputation was impeccable. The company believed Cooper would ensure the bridge's success. Cooper made a critical decision early in the planning process. The original design called for a span of 1,600 feet, but Cooper decided to lengthen it to 1,800 feet. Why? Longer span meant fewer piers, which reduced costs. It also meant the Quebec Bridge would be the longest cantilever bridge in the world, surpassing the fourth bridge. Cooper's ego and the company's budget both benefited, but lengthening the span increased the load on every structural member. Cooper ordered new calculations, but the work was rushed and contained errors. The bridge was now heavier than the original design anticipated, and the steel members were undersized for the loads they would carry. Construction officially began in October 1900. Prime Minister Wilfrid Laurier laid the ceremonial cornerstone. Workers began building the massive concrete piers that would support the bridge's arms. The Phoenix Bridge Company of Pennsylvania was contracted to fabricate and erect the steel. Work was slow but steady. By 1907, the south cantilever arm was nearly complete. The bridge was starting to take shape. And then the warning signs appeared.
By the summer of 1907, the Quebec Bridge's south cantilever arm was extending out over the St. Lawrence River. The structure was massive. Each compression cord was made of steel latticework weighing over a ton per foot. Workers crawled over the steel framework like ants, riveting beams and hoisting materials with derricks. The work was dangerous. Men balanced on narrow beams hundreds of feet above the water. One slip meant death. In late August, Norman McClure, the on-site inspector, noticed something alarming. The lower compression cords on the south arm were bending. The steel was visibly misaligned. McClure measured the deflection and found it was significant. This was not normal. He immediately wrote to Theodore Cooper in New York. Cooper's response was dismissive. He theorized that the beams had been hit by suspended equipment during construction. He told McClure not to worry. McClure wasn't convinced. He sent another letter with more detailed measurements. Cooper again dismissed the concerns. On August 27th, workers on the bridge noticed creaking sounds coming from the steel. Some of the compression cords were making audible groans under the load. The erection foreman stopped work and reported the problem to Edward Hoare, the chief engineer for the bridge company. Hoare inspected the bridge and decided the sounds were not cause for alarm. He ordered work to resume. But McClure knew something was wrong. On August 29th, he traveled to New York to meet Cooper in person. When Cooper finally saw the measurements and photographs, he realized the problem was serious. At approximately 3 in the afternoon, Cooper sent a telegram to the Phoenix Bridge Company. Add no more load to bridge till after due consideration of facts. The telegram arrived at the Phoenix Bridge Company offices in Pennsylvania, but it was never forwarded to Quebec. Communication in 1907 was slow. There were no phones on the construction site. Messages had to be physically delivered, and that afternoon, no one carried Cooper's warning to the bridge. At 5:30 in the afternoon, near quitting time, the south arm of the Quebec Bridge buckled. The lower compression cords that McClure had been warning about for days suddenly failed. The steel twisted and collapsed. In 15 seconds, the entire south arm and part of the central section crashed into the St. Lawrence River. 19,000 tons of steel fell nearly vertically. The sound was deafening. Workers on the bridge had no time to react. They simply fell. 86 workers were on the bridge that afternoon. 75 were killed. 11 survived with injuries. Some were thrown clear of the wreckage and swam to shore. Others were pulled from the water by rescue boats, but most were crushed instantly by the falling steel or drowned in the river. Bodies were recovered for days. Some were never found. The collapse of the Quebec Bridge shocked the world. Newspapers across North America and Europe covered the disaster. Photographs of the twisted wreckage filled front pages. The Canadian government immediately launched a royal commission to investigate. 3 prominent engineers were appointed to determine what went wrong: Henry Holgate, John Carey, and John Galbraith. The investigation took months. Engineers examined the wreckage, reviewed design documents, and interviewed survivors and witnesses. The Royal Commission's report, issued in February 1908, was damning. The commissioners placed clear blame on 2 men, Theodore Cooper, consulting engineer, and Peter Schlopke, chief designing engineer for the Phoenix Bridge Company. The report stated that Cooper had specified allowable stresses that were too high. He had failed to require proper recalculations when the span was lengthened, and he had ignored clear warning signs from on-site inspectors. Schlopke was blamed for defective design work, particularly the inadequate latticing on the compression cords that failed. But here's the most disturbing detail. Cooper never visited the construction site, not once. He made every decision from his office in New York. He relied entirely on letters, telegrams, and reports from inspectors he had never met. When McClure warned him about the bending steel, Cooper dismissed it without seeing the bridge in person. His arrogance and overconfidence killed 75 men. Despite the Royal Commission's findings, neither Cooper nor Schlopke faced criminal charges. There was no legal framework to prosecute engineers for negligent design. Cooper's reputation was destroyed, but he remained free. He died in 1919 of pneumonia.
his legacy forever tainted.
Among the 75 dead were 33 Mohawk steelworkers from the Kanawake Reserve near Montreal. The Mohawk people were renowned high steelworkers. They had no fear of heights and were prized for their skill and courage. Entire families from Kanawake worked on the Quebec Bridge. When the South Arm collapsed, fathers, sons, and brothers died together. The Kanawake community was devastated. An entire generation of steelworkers was lost. They were buried under crosses made from twisted steel beams recovered from the wreckage. The Quebec Bridge Company was ruined. The bridge was unfinished. The investors had lost millions. But the Canadian government decided the bridge was too important to abandon. In 1911, the federal government took control of the project. 3 new engineers were appointed: Ralph Modjeski from Chicago, Maurice Fitzmaurice from Britain, and H.E. Vautelet as chief engineer. They designed a completely new bridge with much stronger structural members. Construction began again in 1913. The new design was more robust. Every detail was triple-checked. Government inspectors monitored every step. By September 1916, the bridge was nearly complete. The massive center span, weighing over 5,000 tons, had been built on barges in Sillery Cove and floated into position. On September 11th, the span was being lifted into place using hydraulic jacks mounted on the cantilever arms. Thousands of spectators gathered on shore to watch history being made. At 10:30 in the morning, the lifting operation resumed. The span rose slowly, inch by inch. Engineers and government officials stood on the cantilever arms, supervising. At the intermission, they came ashore. That decision saved their lives. At 10:50, a sharp crack echoed across the river. The southwest corner casting of the lifting equipment failed. The massive span slid off its supports. In seconds, the 5,000-ton center span plunged into the St. Lawrence River for the second time. 13 workers died. 14 were injured. Rumors of sabotage spread immediately. World War I was raging. Some believed German agents had sabotaged the bridge. But the investigation proved otherwise. The failure was caused by a defective steel casting in the lifting jack. Another engineering failure. Not sabotage, just poor design and inadequate quality control. Franz Lichtenberg, the engineer responsible for the center span construction, had warned Chief Engineer Vautelet about problems with the lifting equipment 6 weeks before the collapse. Lichtenberg noticed cracks in the castings. He recommended replacing them. Vautelet dismissed the warning. He was wrong. 13 more men died.
After the second collapse, many wondered if the Quebec Bridge was cursed. 2 catastrophic failures, 88 dead. The project had consumed 20 years and millions of dollars. But the Canadian government refused to give up. A duplicate of the failed center span was fabricated. On September 17, 1917, the new span was successfully lifted into place.
This time, the operation went flawlessly. The Quebec Bridge was finally complete. The bridge officially opened to rail traffic in 1919. It was the longest cantilever bridge in the world, a title it still holds today. The main span measures 1,800 feet. The entire structure is over 3,000 feet long. It stands as a marvel of engineering, but it is also a monument to failure, tragedy, and the cost of ambition.
The Quebec Bridge changed engineering forever. The disaster led to major reforms in how bridges are designed, reviewed, and constructed. Engineering societies established stricter standards for peer review. The idea that one engineer, no matter how experienced, could single-handedly design a major structure became unacceptable. Today, large bridges require teams of engineers, independent reviews, and rigorous safety checks. But questions remain. Why was Theodore Cooper never prosecuted? Why was he allowed to make critical decisions from hundreds of miles away without ever visiting the site? Why were the warnings from on-site inspectors ignored? And why, after the first collapse, did engineers make the same mistakes again in 1916, ignoring warnings about defective equipment? The Quebec Bridge still stands. Trains cross it daily. But beneath the water, at the bottom of the St. Lawrence River, lie the remains of the second center span. It was never recovered. It's still there, a silent tomb for the 13 workers who died when it fell. The Kanawake community never forgot. For decades, Mohawk steelworkers continued to build bridges and skyscrapers across North America. But they carried the memory of August 29, 1907, the day the Quebec Bridge took 33 of their best men. The Quebec Bridge is a paradox. It's an engineering marvel and a catastrophic failure. The longest cantilever bridge ever built, and the site of the deadliest bridge construction disasters in history. 88 men died building it. 2 collapses, 9 years apart. And the engineers responsible faced no criminal consequences. What happened to Theodore Cooper's detailed correspondence with the Phoenix Bridge Company? Why were critical documents missing from the Royal Commission's investigation? And why did Franz Lichtenberg's warnings about defective castings go unheeded in 1916? These questions linger. If you want to uncover more stories of American and North American infrastructure hiding dark histories, subscribe to Hidden America. Next time, we'll explore the construction of the Hawks Nest Tunnel in West Virginia and discover how over 1,000 workers died from silicosis in what became America's deadliest industrial disaster. We'll investigate the cover-ups, the mass graves, and why most of the victims were black workers whose deaths were systematically undercounted. Subscribe now for more hidden infrastructure stories. And remember, every great achievement has a shadow. Sometimes that shadow is made of 88 graves and 2 collapsed bridges at the bottom of a river.